So let's take a look at particle motion. Now, the position function of a particle can be written as s of t. So this function will give you the position of the particle at any given time t. And since t represents time, time always starts from 0 and then goes on from there. So we have to say that t is greater than or equal to 0. Now, if you go ahead and derive s of t and derive the position function, you'll actually get the velocity function in terms of t. So this will give you the velocity of the particle at any given time t. So v of t can also be known as s prime of t, since it's the derivative of the position function. And now if you want to find the speed of the particle at any given time t, speed is equal to the magnitude of the velocity, or in other words, the absolute value of the velocity function. So that will give you the speed at any given time t. So for these next set of problems, a particle moves according to the law of motion s of t. So realize that's going to be our position function, where t is greater than or equal to 0, and t is measured in seconds and s is measured in feet. So for part A, we have to find a velocity at time t. For part B, what is the velocity after 3 seconds? Part C, when is the particle at rest? Part D, when is the particle moving in the positive direction? And finally, find the total distance traveled during the first 8 seconds. So for number 1, we have s of t, our position function, is equal to t squared minus 10t plus 12. So once again, for part A, find the velocity at time t. Well, v of t, the velocity function, once again is equal to the derivative of the position function. So all we have to do is derive t squared minus 10t plus 12. So the velocity function is going to be the derivative of t squared is 2t, and then the derivative of negative 10t is going to be negative 10. And the derivative of 12, just a constant, is 0. So we're just left with 2t minus 10. If I go ahead and write that down. So now for part B, we have what is the velocity after 3 seconds. So we obviously have our velocity equation, and we're trying to find the velocity after 3 seconds. So all we have to do is plug in 3 for t, because t is our time variable. And it's after 3 seconds, so we plug in v of 3. So that'll be 3 times 2, which is 6, minus 10. So then we get a velocity of negative 4. Now, since s is in feet and t is in seconds, then the velocity units are going to be negative 4 feet per second. So now for part C, we have when is the particle at rest. So when a particle is at rest, obviously it's not moving, so that means the particle is at rest when the velocity is 0. So all we have to do is set the velocity function equal to 0, so we say 0 equals 2t minus 10, and we solve for t. So then 2t equals, we add over the 10, and then t is equal to 10 over 2, or 5. So at t equals 5, that's when we know the velocity is 0, or when the particle is at rest. Now for part D, when is the particle moving in the positive direction? So when a particle is moving in the positive direction, its velocity is going to be positive. So we have to say that v of t is greater than 0 when the particle is moving in the positive direction. So we can go ahead and set 2t minus 10 to be greater than 0, and then we find the t value. So 2t is going to be greater than positive 10, so then t is going to be greater than 5. So we know that when t is greater than 5, or after 5 seconds, the particle is moving in the positive direction where its velocity is positive. So now for the last part E, I had to reword that question a little bit, so now it asks find how far the particle is from its starting point at 8 seconds. Now in order to answer this question, we have to go back to our original position function s of t. Now looking at the question, we're going from its starting point to the 8-second mark. So we're basically going from t equals 0 to t equals 8. Now in order to find how far the particle is from its starting point, in the first 8 seconds, all we have to do is take s of 8, so plug in 8 for t, and then minus s of 0. That's the starting point when we plug in 0 for t. So let's go ahead and find s of 8. So for s of 8, all we have to do is plug in 8 for t. So when I do that, we'll get 8 squared, which is 64, minus 8 times 10, which is 80. If we go ahead and rewrite 80 there, and then plus 12. Now 64 minus 80 is negative 16. Negative 16 plus 12 is going to be negative 4. So that's going to be s of 8. Now s of 0, if you go ahead and find that, we just plug in 0 for t. So we get 0 squared, which is 0, minus 10 times 0, that's also 0, plus 12. So that's going to give us a value of 12. So once again, we're going to take s of 8, which is negative 4, minus s of 0, which is 12, and that'll give us negative 16. Now, this is asking for how far the particle is from its starting point. So basically, its distance from the starting point. Now, you don't say you're negative 16 feet from someone, you just say you are 16 feet from someone. It doesn't matter what direction it is. So instead of the negative, we take the absolute value of it and just make it positive. So the particle is going to be 16 feet away from its starting point during the first 8 seconds.